Hello, this is Radek Maca from CFD support, and in this video I am going to show you how to create a connection in cases with TCFD. So I will be showing this example on a particular geometry of a simple axial fan geometry consisting of two parts, rotor part and the stator part, and create it just as a segment, not as a full wheel geometry. So the connection in cases is done with this software connector. So I will create a new one, and what the connector needs. So first section is about the input geometry. So input geometry will be given from the CAD, from the cases CAD. Then the input files is the input files of any software should be connected to cases. So in this case we would need the input files from TCFD. So the most important part is the configuration file, which includes the best setup for your simulation, giving you the best simulation results. Then result files are really important because to run the optimization loop, you have to define the objective function, which could be, for example, efficiency, any other quantity. So here you need to put inside some results files from TCFD. So therefore you have to create the template case, which is perfectly set and gives you the results, and these results then can be put here and to be connected with cases as well. So the result values and maybe result files, including some visualization and so on, but I will be not showing this. So input geometry, input configuration TCFD file, and result files from TCFD simulation. To be able to create a templated configuration file, we need to first export the geometry in a proper format. So I will start with this. So in this case I have ready to export components of this geometry, rotor and stator parts. So I will export them in the proper format, which in this case can be, for example, the multi-body STL format. So okay, I'm the cases axial fan folder, and I will create a new folder and name it, for example, temporary TCFD case, okay, in which I will export the stator parts of temporary stator, for example. Perfect. And the same I will do for the rotor part. So multi-body and temporary rotor. All right. So this is my export, just to check that. Okay, temporary TCFD case, and I have these two files which will be the input geometry to my TCFD simulation. The next step is to prepare the TCFD simulation for our exported geometry. So we can open TCFD graphical user interface. Now we are using the version 19.04. So we preset the standard simulation setup in a usual way, following your current experience or based on the webinars you can follow. So first of all, I will create the configuration file. Yes, so I am in my working directory, TMP TCFD case. So I will create, for example, TMP setup configuration file. Okay, no STLs, of course, because I will clear it, and I need to input my exported geometry. So I will have two components, one multi-solid file. Yeah, directly it can see this rotor file, and the same for my second component, which is the stator, right? Just let me check the geometry, everything was correctly loaded, so we can fill the rest of the setup items in a standard way. So let me now jump in time a bit. So I have tested my setup, I run the simulation, I redefined, let's say, the mesh to follow all the aspects of CFD, and now I'm ready to run the final simulation. Yeah, so everything is preset. I will be using 16 processors because my computer has 16 physical cores. I set 3 points to be simulated with different volumetric flow rates to really see some short performance map for my Excel file as an example, and the revolution speed is 3000 RPMs. In the post-processing, nothing special, only I have one efficiency probe to really evaluate the overall performance of my whole geometry, means including both rotor and stator part. Okay, so now I can go for the simulation. So I will apply the TCFD manager. Okay, I will create for the simulation, for example, the TMP simulation folder in which my final simulation will be stored. So write case in the standard way and run the calculation. And now the simulation is finished. We can follow, for example, the HTML report if everything is really okay and ready for the connection with CAESES. It means if really we are satisfied with the results and so on. Before the connection itself, I would like just to mention what data or what files we will put into the software connector. So first of all, it is the configuration file, which includes all the parameters necessary for TCFD simulation. So this file can be loaded by CFD processor, which can be used to run TCFD simulation without graphical user interface, which reads this file. And from the simulation itself, we need to take the results, and the results are stored in the post-processing efficiency directory, and we can go into the efficiency minus final CSV file, which includes all the evaluated parameters, so all the integral values averaged over the given part of the geometry. And for example, we will take the efficiency, we need to take the average efficiency, of course, and we can take average efficiency of each simulated point. So this file we will put into the CAESES to be able to get the results from each simulation for every design variance and so on. So these at least these two files we need to have for creating the connection. Now we are back in CAESES, having everything ready for creating new software connection. Let's do that. Let's click here on this icon, create new connection and software connector. So this is it. First we will set the input geometry. We can just go to the cat part and drag and drop the rotor and stator part. Now we are going to modify some parameters of this input geometries. First, we can set our own name for the export, and we have to set the same export type as we did as we have used for setting TCFD simulation. And the same we can do for the rotor part. of the axial fan geometry and multi-body STL. So this is it. This is setting of input geometry. Now the input files. So here we have to put all the configuration file or all the files which TCFD needs for the simulation. So in general, it just needs the configuration file and the geometries, which is already set here. So we need to find our preset configuration file. So I am there already. Let's open or let's add this file which contains all the configuration we set in graphical user interface and test it. Input files and result values. So here we put inside the result file from our template simulation case. So let's go for post-processing efficiency 0, and we take this efficiency minus final CSV file. Okay, so now we have to define which values should be taken from this result file. What we can set here in the general, we can set template name efficiency minus final. So this, for this file, CAESES will be looking for after the simulation, and here we have to define the subfolder from the root directory in which CAESES will be running. Basically, it corresponds to our structure we created here. So the folders from which we run the simulation. So let's navigate to our case, to the post-processing efficiency and 0. So basically here, if I take this structure, this will create my subfolder structure in CAESES, and I will put it here. And then we can just know that the TMP simulation is the name of a folder in which TCFD simulation is stored. So let's modify it to, for example, TCFD simulation, and then this parameter will be put it later on in the part where we define the executable for running TCFD in the background. So let's take in this way, and now we can create the parameters or the values which will be taken from this file, and these values will be then available for CAESES and, for example, for optimization loop and for defining the objective function. So let's create, let's say, 3 parameters which takes the efficiency for each simulated point. So simply here I can define line and the column. So column will be second, starting from 0, where the efficiency average is stored, and I will name it as, for example, TCFD eval minus efficiency, or underscore efficiency 1, let's say underscore, in this way. And then I can create the rest. My second line will be second, and last but not least, third efficiency, and line, third line. Okay, and to be available for CAESES, I will make them as a parameter. So I will create parameters from them, and then we can see here in this baseline, in this window. And this was an example of setting the input values. It should be connected to CAESES and taken from TCFD. Now we can go back to the connector and discuss connection of TCFD parameters with the CAESES parameters. First, what should be connected is basically are the input files. So the connection in this case can be done pretty easy. First, we need to find the parameter which holds the name of the input STL files, which, if I remember correctly, is the file path parameter. Here we can see, here is our former TMP rotor file, and we need to put here from the entries by right click, entries. From the exports we can assign here the rotor.stl which we defined here in the input geometry. And the same we need to do for the stator part, which is the component 2. So we need to locate 2_ file. So let me here, and I will connect it to the exported stator.stl. So perfect. And now for every instance, for every geometry variance, always we get the proper path and proper file from the input geometry. Okay, and now we can also connect any parameter from the parametric model, let's say, or any parameter which is created in CAESES with our configuration file. So as an example, let me show you that, for example, here the parameters of the model's parameters are, for example, rotor, number of rotor and number of stator blades. And TCFD needs to know how many blades in each region builds the full wheel, because all the transformation to create a segment is dependent on the number of rotor or stator blades. So let's connect the parameter to the parametric model, which is number of periodic segments here. So I can click. Now we have a new config parameter called number of periodic segments. So I can rename it, and for example, and this is component 1, which is rotor, so number of rotor blades, let's say. It should be integer, and the value will be the parameter. So we can have a number of, here is the parameter, number of rotor blades, so I can put it just here to be always followed by our parameter, or by parameter of the parametric model. And the same I can do with the number of stator blades. So this is here. So create new parameter. I will just rename it to stator blades. Type should be integer always, and the value will be taken from the parameter here. Okay, and perfect. And now anytime we change the number of rotor or stators, it will be copied into the configuration file, and TCFD will run properly for any variant of number of rotor or stator blades. And in this way we can create any parameter. For example, if you would like to somehow set the number of processors, for example, so we can create the parameter processor. Let's say TCFD processors. Type should be integer, right? Because double doesn't make any sense. And the default value, because my computer has 16 cores, I can set as 16. And now I can clearly and easily change the number of processor for the simulation by changing this parameter and not going into my configuration file. So based on your problem, based on your goal, based on your parametric model, you can connect any parameter from the configuration TCFD file and with the CAESES parameters. Whenever we are done here, we can go back to the software connector, and the last item we need to set is the runner. So basically this is the defining of the executable of, or defining the script which runs the process behind the CAESES. So let me show you two options first option is to directly locate the application which can run TCFD on background. So for this purpose, the executable is the CFD processor which manages all behind. So we need to find them, and if you use a standard installation process, you will find it on your C drive in the TCFD directory based on your version. I will take this 19.04 version. Inside the binary directory, you will find this CFD processor. So this executable can manage all the process behind the graphical user interface. So this is the executable, and the arguments are, you can find it in the manual. It reads the argument setup, which holds the setup file. In our case, it is called TMP setup, so it must follow this name, .tcfd. Then minus there, which is defining the directory in which the simulation will be stored. So here it must follow basically it must be in comparison with the file with the directory defined here. So I will take this one, because then CAESES will be looking for the results in the file efficiency minus file under this path, under this subfolder structure. And there is an option to run everything by one command, and it is option which is called minus all run. So it basically runs everything by one click. Okay, and this is it. We can rename the runner as, for example, TCFD runner, and this is it. I strongly suggest to running this test simulation to validate your setup, your configuration file, to validate if your input files and the parameters are well connected, as well as if the result values are successfully taken at the end of the simulation. You can follow the simulation process in the task monitor here on the sidebar. And for example, here is my running simulation now, and basically you will see at least here if everything is running successfully, and if you can see standard TCFD output during the simulation. And at the end of the test simulation, you should be able to evaluate the efficiencies taken from the TCFD simulation. So let's go for it. Perfect, it works. So you can see that we successfully defined a connection between the TCFD and the CAESES software. A second option how to define a runner is to use a script. Script gives you more options to define the workflow complex. For example, you can create a script which runs several software tools, which runs several independent scripts, and so on. So let me show you a simple example. So we can create a script, for example, run TCFD VAT, in which we define just the executable with the proper options. So TCFD version 19.04 bin folder and CFD processor.exe, and provide the proper options. So this is TMP setup.tcfd, directory is TCFD simulation. This directory has to be same as the directory or subfolder in the result values, where we input the efficiency final CSV file, just to mention that again. And we would like to run it all. So now I saved the script, and we can put it here. Perfect. And whenever we have the file here, we can define a runner. Let's call it TCFD runner script, using this script. Okay, just edit. I don't need executable, and I will provide just the name of the script. Okay, and I don't need any arguments, of course, in this case, because the arguments are placed inside the script. And now let me check if this setup is working. Okay, let me show run TCFD.bat, and you can see the TCFD simulation is running perfectly. Okay, so this is the second option, how to create a runner. And at the end of this video, let me show you a simple optimization. So first of all, we need to have the objective function to be minimized. So we can create parameter which will be used as an objective function, and we define the objective function as a sum of our efficiencies for all the 3 points simulated. Okay, so we can define the objective function as a sum of the efficiencies. Okay, I need to provide all 3. Okay, that's 2 and 3. Let me check that. Okay, and because we are going to, or the optimization process minimizes the objective function, we have to provide the negative value of the sum of efficiencies. So in this way, okay, just to correctly provide. All right, so this is the sum of all the efficiencies with the negative sign. So now we can go for the optimization. We create a simple design lab, so we will create each variation manually. The design variable is number of rotors. Very simple optimization. The evaluation function will be the objective function, which will be the objective. And for example, I would like to see the efficiencies separately as well, and I don't want to include them as objective functions. We can add also some constraint if the simulation is broken, or some limits to the parameters, but this is not the purpose of this video. So let me now create, let's say, 3 design. First design will include, let's say, 8 or 7 rotor blades. The next design, which I am going to create, okay, I will set with 9 rotor blades. And the last one, let's say 11 rotor blades. Okay, and now we can wait for the results. So now each design variable, or each design variation, is created and afterwards simulated with TCFD. And at the end of the optimization process, we can see all the results in this table, and just to follow the numbers, we can see that really the efficiency is, let's say, linearly dependent on the number of rotor blades. Okay, and in this way you can set any kind of the optimization process as you want with the help of TCFD as a CFD simulation tool. So thank you for watching, and see you next time. Bye bye.